Okay, today we are talking about inductive reasoning. It's a fancy word, but it just means uh, when you kind of just notice a pattern, and you predict what the rule is, or what's happening, or what's going to happen next. Like if I said 1, 2, 3, what am I probably going to say next? 4. So that's inductive reasoning. It's not something you know for sure is true, but based on evidence, based on what you do know, that seems like what's right. Inductive reasoning. So there's patterns like that, but there's also like if I walked in from outside and I was wet, what would you maybe think?
It's raining.
He's sweating.
It's raining, probably. Or maybe it could be something else. Somebody.
It's not outside.
There's a couple other ways to get wet besides rain, but it's probably raining. Anyway, that's inductive reasoning. So it's kind of like an educated guess. What's the word I'm looking for? Conjecture. Yeah, that was it. The conjecture is the educated guess. Yeah, it's kind of like this is what I think it is. That's a conjecture. Okay, that's opposed to mostly in geometry we will be using deductive reasoning. Inductive reasoning you would use to like make a hypothesis, like in science or something. Deductive reasoning is more like it has to be true if your assumptions are true. So if I say everybody in geometry is a sophomore or a freshman, and then I say Jaden's in geometry, then what must be true?
He's a sophomore.
He's a sophomore or freshman. So that's deductive reasoning. And we're not doing that today, but that's more like, that's what geometry is, mostly like proofs and stuff. But we're just doing this today. All right.
So would coaches use inductive reasoning to kind of like figure out like what plays would be next? Like to like who gonna stop?
Like to predict what the other team's going to do?
Yeah.
Yeah, I guess.
Once we go to sleep.
Okay, number 1. So we're just supposed to figure out the patterns on these. 1.4.9. What's the last one going to look like?
4x4.
4x4. So you just draw it. Some of these are tricky on 1 through 9. I remember counting 6 wrong a lot in the past. I have memories of grading these pages. Okay, anyways, number 3 is kind of tricky. Well, it's definitely going to be a square with the diagonal, like the X and the cross in it. Because they all look like that. But which ones do we fill in? Here, I'll number them. So. It's like a clock. Corey says 1 and 5. Do you guys agree? Disagree? Can you tell me why you agree, Willie?
Because Corey's smart.
That's inductive reasoning. Well done. Okay. Okay, well, it's kind of like a fan, like a couple fan blades, and they're turning clockwise. I guess the only ones that aren't filled in the other 3 are, 1 and 5. These 2. Is that you?
What?
That was you?
What?
Humming? Were you I mean, come and get your love. Is that what it's called? That's the song. The chorus is "Come and get your love." Oh. All right, I did. That wasn't an invitation to start singing.
I'm just glad Skylar's in here.
Okay, how about number 5? She probably doesn't know it.
That looks complicated.
It's from before 2000, so she does know. Let's look at the big shapes. What's the pattern with the outside shapes? Triangle, square, something, hexagon. So what's the pattern?
Pinta.
Yeah, it's going in 3, 4, 5, 6. So it's a pentagon. You guys know how to draw that?
No.
Okay, but what about all the lines on the inside?
It would go to every single corner.
Be a star.
Yeah, they're called, it came up once in chapter 1, these are called diagonals. They just go from one vertex to another, so you draw all the diagonals in there.
Quit shaking.
That looks like something that I don't want to do. Looks like
Yeah,
These are goofy.
Am I the only one that doesn't know what this is?
Yeah, what's
This is so weird.
Look at the what?
you didn't see the pattern in 5?
No, I get those.
Oh, on
but,
6.
they're just also like. I
It's
don't
like
know,
a-
very
it's like a-
complicated.
You gotta think about it, it's a brain teaser.
It's
It's
not.
like
I don't
a
like my
tournament
brain.
bracket. Number 6.
Yeah, 6 is kind of like a tournament bracket. Okay, on 7 we got, they're all triangles on the outside, so start with triangle. And then it goes a triangle in the middle, it's filled in. So what do you think is going to happen after the triangle in the middle?
Medium triangle.
Yeah.
So this one's like filled in, so you're not supposed to put anything in there, but. Yeah, so notice this triangle in the middle, it like touches the midpoint of each side. So that would be like that. I guess you could color these in too, technically, but I wouldn't worry about it.
Whoever made these obviously doesn't like
Could be, could be.
Or doesn't like Whitney.
What?
Hmm?
That's a demerit word day over there.
No.
Okay, what shape, what's going on number 9? The big shapes are hexagons. Okay, you might want to draw it kind of big as the other stuff. Okay, so what's going on in the second picture on number 9?
Scary thing.
What happened?
It shifted.
They added more.
One on the inside, but it's like
Yeah, there's a hexagon on the inside. You guys see it? So how'd they draw it though?
hit every line in the middle.
Yeah,
Oh,
the
that's-
vertices hit every midpoint
I did it wrong.
of the segment, so it's kind of like hitting those 6 points.
That's not
See, it's beyond you.
This is too.
Oh, well, that's the second one, so we need another one, right?
Yeah.
So it's gonna hit the midpoint of every side. Kind of missed.
Mine looks so bad.
Doesn't look.
If you get the point of it though, is it fine? Yeah.
Holy cow, this is bad.
Look at mine. What is that? Yeah, if I just
I wonder if you kept going,
That's so bad.
what it would look like.
Looks like the Doctor
No, that's
Strange
supposed to be
peanut
an
butter.
That's what mine looks like.
Whoa, look at mine.
It looks like a rose. Oh goodness.
Oh my.
Doctor.
It looks good though.
Guys,
No, it's possible.
so if it looks like.
Maybe it's tighter than no.
It's a rose.
Kind of like a spider web.
Oh, not a
What?
rose. I think more of a rose.
Don't draw that. Oh yeah, rose, yeah.
I said that.
It was wrong when you said
Mr.
it.
Jordan.
Number
Hey,
11.
Mr. Jordan, have you seen Spider-Man Across the Spider-Verse?
Is that the one where there's 3 Spider-Men?
No, it's the newest one.
Oh, is it a cartoon one?
Yeah.
I haven't seen it.
That's what it looks like.
There's no-
That's what I feel like
there's
it's
no-
No, no.
That's the picture.
Okay, number 11 is, we're to numbers now, so if you like numbers better than
Yay.
pictures. Okay, so it says find the next 2 numbers in the pattern.
The next 2 numbers?
Yeah.
No, it's 5.
You know what?
Anyways, so what's the pattern on number 11?
Kind of by 5s.
Number 11.
Oh.
It's the,
Oh.
it's the negative.
How do you go from 3 to -6 to 12 to -24?
So you're doubling it, but every other number it's a negative.
Yeah. How do you double a number and make it opposite?
To the greatest power. Or to the power. Wait. What? I don't know.
Oh, it times by 2.
Times by
Negative 2.
Times by -2. So what's 48 times -2?
48. Negative 100.
Not
Oh, yeah, 96 on that.
-96 times -2.
192. I'm literally so smart.
Or he listening.
No, I just waited for Mr. Jordan for
13. All right, this one stumped the other class.
You won't stop
Why
us
is
this
that?
time.
Am I gonna stump us?
Oh, what? I'm stuck.
Yeah. Oh, what is
I
What
know,
is
I
that?
know, I know.
The next one is 6 and then 6.
No.
And then the next one after that is 8.
I'm still going.
It would work though, 8. Let's be honest. It would
All right,
work.
Lennox.
Is it like times 1?
Oh, I got it! I got it. So 1 plus 1 equals 2, and then 1 plus 2 equals 3, and then 2 plus 3 equals 5, so 3 plus 5 equals 8.
Oh, good job.
Bro,
And
who
then
thinks
5
of
plus
this
8
crap?
equals 16.
Good job, bro.
13.
Or I meant 13. I meant 13.
Never mind.
No, I see. I understood.
Roman, you're smart. Never mind.
I mean, what I said was the
I'll listen to what's on there.
Get it? Not wrong.
Who went with them smarter than Grant?
I
No way, it's not that class.
Oh, okay.
It's like smarter than anybody here. In the-
Bro.
5 years.
Okay, yeah, the other class is a mix of sophomores and freshmen. So, anyways, 15.
Number 15.
1, 2, 6. They did figure this one out, so you guys can't let them beat you.
Times 2, times 3, times 4, times
Okay, he's got it. Times 2.
Let's freaking go. What you guys are fixing?
Wait. Okay, they went to 120. So we need. You guys know your 12s. What's 12 times 6?
72. Wow.
Okay, so it's 720. Oops. Times 7. That's kind of hard.
500. Oh.
I'm
5,000.
So those
knew
are.
that before you guys even said it.
Okay, 16 was pretty hard, so I decided to make it a bonus. You guys notice that?
16.
But I gave you a hint. It has something to do with exponents.
Oh, I know it.
No, don't say it.
I know it.
No, we're not doing that one together. It's even. Okay,
Oh, I don't know.
number 7. Verify Goldbach's conjecture for each even value n. Show that each given number can be expressed as the sum of two prime numbers. What are prime numbers?
Numbers that nothing goes into.
Is that what?
Nothing goes into it
Well,
except itself and one.
yeah. All prime numbers have two factors. All prime numbers have two factors. One times itself. So what's the smallest prime number?
One.
A 1 only has one factor, so you have to start with 2.
Three.
Is 4 prime?
No.
No. 5,
Yes.
6,
No.
7,
Yes.
Yes.
Is it 17?
8,
Wait, what's up?
No.
What's the number again?
9,
No.
10,
No.
11.
Yes.
Yes.
Okay, and it goes forever. But these are some of the small ones. The smallest primes, because nothing multiplies into these numbers besides 1 times itself. Two factors. Yeah. So, Goldbach's conjecture, this guy named Goldbach thought that all evens are the sum of two primes. So we got to show that it can work on these. What primes would add up to 4?
2 plus 2.
2 plus 2. So just put, 2 plus 2 is 4. 19. What primes would add up to 8? 5 plus 3. What was the last one? 12. What is up to 12?
You can only use 2.
How many, can you use more than 2?
5 plus 7.
No, just 2.
Can you use the same one twice? Yeah, you can. What's the second?
Didn't you give the answer to number 17?
No.
Okay.
That was wrong, remember?
23. Make a conjecture describing each instance by completing the sentence. The product, so it's just, based on what it looks like. The product of negative and positive number is
Negative.
negative. I don't know if we know that by inductive reasoning more than just the teacher said so, or the book said so. But it's just 25. The length of a rectangle's diagonals are rectangles.
Equal?
What are diagonals?
Uh,
These things, right?
yeah.
What do you think we know about their diagonals?
They intersect?
The lengths of diagonals
They're equal.
equal.
Be like Paxton. Oh yeah, I knew his face.
Okay, on the last section, 27, 28, give a counterexample to disprove. So if you make a statement, it can be disproven using one counterexample. Like if I said, I don't know, all, if I said all cats have hair, or something like that. You could give one counterexample to disprove the statement, right? That's,
Hairless cat.
yeah, here let's go. Okay, so on 27 it says,
2 plus
the sum of any two prime numbers is even.
No.
So we gotta give a counterexample. How is that not true?
2 plus 5.
Okay, yeah. When you do 2 plus 5 or 2 plus 3 or something, those are two prime numbers, but the answer is not even. Alright. That's it.